Hello everybody and welcome to our final video of Unit 2, Solution Stoichiometry. Before we begin talking about solution stoichiometry and doing some examples, let's focus on how we can calculate the number of moles of something. As you remember, a mole will equal 6.023 times 10 to the 23rd of anything. A mole equals the atomic mass of an element in grams. A mole also equals the molar mass of a compound in grams. A mole will equal 22.4 liters of a gas at STP. And from our last video, we learned that a mole will equal the molarities of a solution times the liters of that solution. When doing solution stoichiometry, is it any different than the stoichiometry that you've done in the past? Well, believe it or not, it's not any different. You will follow the same process as before. Let's take a look at an example and kind of refresh your memory on the process of solving stoichiometry problems. Using the following equation, if you have 50 milliliters of a 0.25 molar solution of chloric acid, how many moles of H2 gas are produced? I've given you the equation here. First thing you should do when reading these problems is write down what's given and write down what you're asked to find. So we are given the number of milliliters of the acid and the concentration, 0.25 molar, and we're asked to find the number of moles of hydrogen gas produced. As with any stoichiometry problem, you need to make sure that you have a balanced equation. So looking at the equation above, is it balanced? Yes, it is. I've given you this equation balanced, but you need to keep in mind, not all equations that you are given will be balanced. Now you're going to convert to the moles of chloric acid. To do this, we take our volume that we're given, change it to liters, then we use our molarity, and remember molarity is moles per liter, to find the number of moles of chloric acid in that solution. So now that we know that we have 0.0125 moles of chloric acid, we need to convert to the moles of hydrogen gas. And to do this, we need to go back to our balanced equation and find the mole ratio. So with the moles of chloric acid, we find that for every 2 moles of chloric acid reacted, we will produce 1 mole of hydrogen gas. So using that mole ratio, we can calculate that 0.00625 moles of hydrogen gas were produced. Remember to keep an eye on your significant figures. The first number given, the 50, has 3, so your final answer should have 3. Here's another one. If 0.035 grams of silver chloride forms in the reaction of 3.11 milliliters of 0.11 molar silver nitrate with excess calcium chloride, what is the percent yield? Well, we need an equation before we can go any further. So knowing that silver nitrate and calcium chloride are reacting, this is going to be a double replacement. We know one of our products will be silver chloride. It tells us that in the problem. And our other product will need to be calcium nitrate. Write down your givens. You know the milliliters and the molarity of your silver nitrate, and you know the number of grams of silver chloride produced. Now you need to find the percent yield. If you remember, percent yield requires you to find a theoretical yield. And theoretical yields are based on the mathematics of stoichiometry. So you take the information you know, calculate how much should be produced, and then use what was actually produced, the 0.035 grams, and figure out the percent yield. Before we can get to that point, first question we need to ask is our equation balanced? Looking above, we need to balance this equation. It is not balanced. So to do this, we need to put a 2 in front of our silver nitrate and a 2 in front of our silver chloride. This will make sure that we have the same number of each element on both sides of the reaction. Now that our equation is balanced, we need to convert to the number of moles of silver nitrate. We're going to do this by using the volume of solution we have and the molarity of that solution. So we're going to take the 3.11 milliliters, convert it to liters, and then using the molarity, which is moles per liter, we can calculate that we're going to have 0.000342 moles of silver nitrate. Once we know the moles of silver nitrate, we need to convert to moles of silver chloride. This is our stoichiometry step. We're going to use our mole ratio from our balanced equation. And if you take a look, our mole ratio of silver chloride to silver nitrate is a 2 moles to 2 mole ratio, or a 1-to-1 if we reduce it. So the number of moles of silver nitrate we have will equal the number of moles of silver chloride produced. Once we know the number of moles of silver chloride, we need to figure out how many grams that would be. We need to use the molar mass of silver chloride and calculate the number of grams of silver chloride produced. And in doing so, we find out that 0.0490 grams of silver chloride will be produced based on the sample of silver nitrate solution we use. This is our theoretical yield. If we were able to complete this reaction 100%, no error, this is the amount of silver chloride we should produce. But that's not what was produced. We were told in the original problem that 0.035 grams of silver chloride was produced. To calculate our percent yield, we take our actual yield, that's what we got from our experiment, divide it by the theoretical yield, and that's what we calculated through the math, and times it by 100. If we do that by plugging in our numbers, we can see that we have a 71.4% yield. Here's another example of a solution stoichiometry problem. What volume of 1.212 molar silver nitrate is needed to precipitate all of the iodine ions in 120 milliliters of a 1.200 molar solution of sodium iodide? So we're adding a few more pieces to these calculations as we go along. Here's our equation, and you're going to write down your givens. We know the molarity of silver nitrate. We know the volume and the molarity of our sodium iodide, and we're asked to find the volume of silver nitrate. First question, is the equation balanced? In this instance, it is. Now that we know that our equation is balanced, the second thing we need to do is convert to the moles of sodium iodide. Using the volume of sodium iodide that we have and its molarity, we can convert milliliters to liters. Using molarity, which is moles per liter, we can calculate that we have 0.144 moles of sodium iodide. Once we've calculated the number of moles of sodium iodide, we need to remember that our original question is not asking us what volume of silver nitrate is needed to react with all of the sodium iodide, but instead it's asking for the volume of silver nitrate needed to precipitate all of the iodide ions. So to calculate the iodide ions, we need to take a look at how many iodide ions are in one compound of sodium iodide. In one compound of sodium iodide, if sodium iodide breaks up, one iodide ion is given off. 1 mole of sodium iodide then will give off 1 mole of iodide ions. So if we have 0.144 moles of sodium iodide compound, then we're going to have 0.144 moles of the iodide ions. We're going to use this value to convert to the number of moles of silver nitrate. Take the 0.144 moles of iodide ions, and from the reaction, we can tell that there's going to be a 1-to-1 mole ratio. So we're going to produce 0.144 moles of silver nitrate. So once you've calculated the number of moles of silver nitrate, the problem is asking us to find the volume. We're going to convert to liters of silver nitrate. To do that, we can't use molar mass because molar mass is to convert to grams. Instead, the problem gave us the molarity of the silver nitrate. Using the molarity, we can calculate the number of liters of silver nitrate that we would need. However, in this problem, you will notice that the molarity is inverted. That means the moles are on the bottom and the liters are on top. We can do that. We've done that with density, and now we can do that with molarity, and it will allow us to calculate the volume that we need. So after the calculation, we can find out that 0.119 liters of silver nitrate are needed to precipitate all of the iodine ions out. So congratulations, yay, you have finished all the lectures for Unit 2. You want to make sure that you use the lectures to review any concepts you're still not sure about. They're there for you to view as often and as many times as you need to. And it's now also time to start preparing for the unit test that will be coming up in probably the next week. So you need to make sure that you really understand all of the lectures from Unit 2 so that you're ready for the test.